All right. The Chicago, Burlington, and Quincy, and the Colorado and Southern. And so we were talking about Montana and Wyoming coal and how that changed the complexion of the Burlington. And so I started digging into it, and it's actually quite involved. So I thought, well, I might as well do a whole series of Zooms about it because it was kind of interesting. So we'll go through coal in the United States. This is steaming coal, not metallurgical coal. Two different things. And we'll talk about Eastern coals, and then we'll talk about Montana and Wyoming coal, and then we'll talk about the future of coal. And then as we continue, we're going to go through the Western mining process and how they transload it to rail, because this is a railroad video, and then talk about coal trains, and then how they unload them at the power plant. So if we go back, there are basically 6 types of hard carbon fuels in the United States, coals, really coals and cokes. And the first is anthracite. That is a very hard coal, and it's in here's the area where it is. It's over in eastern Pennsylvania, and it's almost pure carbon. It's a tight structure. It burns very slowly, but it's almost pure carbon is 14,000. This is very close. Bituminous coal is kind of the standard coal. That's what all the steam engines were burning, and most of the power plants were burning from the 1850 to 1950. And the power plants, a lot of them are still burning it. But it's 12,000 BTUs per pound, a looser structure, so it burns pretty nicely. It was great in the boilers, and a little bit less than a little bit of ash, about 5 to 10% ash. And then we get into the subbituminous coal, and that's the big one that in Wyoming and Montana. And that's 82 to 8,800 BTUs per pound. So it's about 2/3 of the heat, but it has a lot of side issues with it we'll talk about. And then lignite is what they used to call brown coal. I think they do in some countries. They have it in England, and they have it a number of countries around the world. It's only 6,500 BTUs per pound. And they still burn some of it in North Dakota and Texas and places like that. And then there's peat, is 4,000 BTUs per pound. And if you remember, they used to burn it in London. And that's why they said, oh, the London fog is so bad. Well, actually, it was the London smog, because it doesn't burn very well. It's full of water. And if you remember, I think it was Governor Perpich that was, remember during the energy crunch back in the 70s and 80s, he was proposing, we have a huge in northern Minnesota, in northern Wisconsin, there's huge peat bogs. And so he was talking about mining that. So we had some kind of energy. Well, it would be an environmental disaster, because that's where a lot of the water that feeds the Mississippi comes from. They're wetlands, and also it's not very economical because it's so wet. And then there's coke, and we'll talk about that, how they make it, and that's just like anthracite, but it has some side effects too, like many things. So the bituminous coal we'll see is in this area, lignite's here, and then we're going to be going through the subbituminous, because that's Montana and Wyoming coal. Well, we'll take a look at mining, because that has affected what's happened with coal. Now, the traditional mine was they would dig a hole in the ground and sink a shaft, and then they had to put cribbing in to keep the shaft from collapsing. And a bigger mine would have 2 holes. One is a coal conveyor, and one is a miner's conveyor. And so they would go down, they would to the shaft, they would dig the shaft, and then they would drift. They call it drifting sideways, and they would drift sideways, and then they had little carts to bring back here. They'd take the cart up to the surface and dump the coal, and the miners go up and down like that. And then there's slope mining, where the coal vein is under the mountain, and you can't get there, so you have to kind of go at an angle, and they would go gradually down. Sometimes they could actually walk down this pretty gradual slope. Drift mining is where the coal vein is almost exposed, or at a level above the surface near the hill, and so they would build all the stuff here and then mine this way. And then they got into open pit
mining in some of the areas in southeast Ohio. They would have big, huge drag lines, and they would, if when the overburden isn't too, the overburden is the dirt that's above the coal. If it isn't too thick, they could dig it off, and then they could dig the coal out, and that's actually the most efficient way to mine. And then this is what they've started doing in West Virginia. That's quite controversial: mountaintop mining. And what they first started to do was they would dig a pit and then move part of the top of the mountain over there and basically do an open pit on top of the mountain. Well, as they kept going, then they started filling up the valleys, and that creates all sorts of problems. You know, let's say there's a valley over here, they just keep dumping the stuff into the valley. And two big problems. Number one, there's usually a river or creek in the valley, and then they get flooding, and they have all this overburden has metals in it and stuff, so they get pollution. The other problem is West Virginia has some of the most beautiful valleys in the United States, and you fill it up with overburden, it's not great. So that's very controversial, but that's what they've tried to do to keep West Virginia coal competitive. And so here's a little bit closer view. They used to, as I said, they used to do it picks and shovels, and then little carts, and then they got horse-drawn carts, and then a railroad, and then finally they got sort of excavators, and then they've done more mining methods since then. So again, the anthracite. This is a Delaware, Lackawanna, and Western coal car with anthracite in it. And you can see it's pretty big chunks. Again, it was 14,000 BTUs per pound. It's only 0.6% sulfur. It's pretty clean, but it burns very slowly. It burns very hot, but it's slow, and mostly underground mining. And so the cost was high. But back in the day, when they were hauling this stuff out of Pennsylvania down to New York and Philadelphia and stuff like that, it was very lucrative. And so as one of the authors said in the book, the Lackawanna and the Lehigh Valley had more money than God. And both railroads have these huge stone viaducts and stone-lined tunnels and gorgeous track. I mean, it was in the early part of the 1900s. It was tremendous what they did, double track and these stone viaducts. You know, they were building for 1,000 years. But unfortunately, the anthracite didn't last that long, and it led to other problems. And burning it in New York City, they ran into the same problem that they ran into in London with smog. The other problem the railroads ran into is, you can see here. Here's a switcher, and the stuff burns so slowly. This Wooten came up with this big, wide firebox. Because it burns slowly, you have to have a huge firebox. It's easy for the fireman because it's really he throws the fire in there, and it's not too thick, and it just sits there and burns. But you have to have a huge firebox. And unfortunately, that they said, well, let's put the cab alongside the locomotive, and we'll call it a camelback. And so the engineer's sitting here, and the fireman's back here. So I'm not exactly sure how they communicated. I suppose hand signals or something. Fireman's sitting back here. He has to load coal into the boiler, and he has to keep the water level up. That's about all he can do. And then the engineer runs the train. But it was hot. You can imagine in the summertime. Usually, here's got the boiler right here. The other problem is occasionally, not often, but one of these driving rods would break, and it would kind of come up into the cab. So you hope it didn't come up in the wrong place. Now you compare this firebox to a traditional firebox. This is a Chicago Northwestern 10-wheeler about the same time. And you can see the firebox is much narrower. In fact, it fits between the drivers. And so that's bituminous coal. You can throw a nice bed in there, and it's fairly loose, burns fairly rapidly. It's got some volatile material in it, and so that burns nicely. That's the bituminous coal. But the anthracite burns very slowly. And this one, they got so wide that they had to put the walkway to the cab back up high, and the air reservoirs up here. I mean, they really made some interesting locomotives. Well, as the locomotives got bigger, they had to figure out a way so here's a 210-2 Santa Fe type locomotive, but the firebox is wide for anthracite coal, and it comes all the way out to the limit of the locomotive. But they were able to kind of squeeze it in here and sort of shoehorn the cab in there. But you can see huge firebox. So that's anthracite, and again, it's in eastern Pennsylvania. That's where it was common. Now we're
So
gonna
are
go
the
Go ahead.
anthracite fields, are the anthracite fields pretty much depleted now, or is it
Yeah.
simply not? Oh, they are.
I think it's a combination of both.
Okay.
Yeah, they got a lot of the low hanging fruit, if you will, the thicker seams and stuff like that. Plus, it's hard to burn, and but I think and the stuff is probably really deep in the ground, so it's difficult to get because you get water and there's methane and stuff like that. So good question though.
I knew it was Eastern, but I didn't realize it was
It's really
localized.
It's really Eastern, yeah. It's really there's probably pockets of it elsewhere, but this was the big
Sure.
area. And so the Delaware, Lackawanna, and Western, which ran like this, they ran basically between New York City and Buffalo. They ran right through this area, and they would haul it to Buffalo and haul it this way, and it the track was unbelievably beautiful. So